And we're back. Alright, I'm going to be stepping into the frame now. This is an experiment that we did with the students last week when we first came back to school. As I just told you, a scientific method requires us to do 5 things. We have to have the question, we have to have a possible solution, a possible answer to that question. We have to set up an experiment, record the data, and come to some kind of conclusion, or just report the data and let other people decide. So, what we do is, we do an experiment in gravity. The question basically is, does gravity pull everything equally? And what we'll be using for this experiment, we'll be using a couple of pencils. I have 2 pencils, relatively the same size. I've got one in pink and one in yellow for you. We're going to hold these up approximately 1/2 meter above the top. Oops, there's my yardstick, meter stick. About 1/2 of a meter above the tabletop here. So I'm going to hold them up relatively equally, and then I'm going to let them go. And guess what? It seems like they hit the tabletop simultaneously. That's all well and good because they're relatively the same size. But what happens when we take 2 pencils and tape them together? Now, logically, the students will tell you, because this is twice as many as this, and this weighs twice as much as this, and we can prove to you, because we did measure this in class, 1 pencil weighs approximately 4.8 grams, or about 5 grams. 2 pencils and the masking tape comes out at about 12 grams. So, logically, this should hit the tabletop from 1/2 meter above the tabletop before the single one does. So let's find out. Well, it doesn't seem to work quite right, does it? And let's try one more time. So, because these hit at the same time, gravity must be working at the same time, pulling at the same rate on everything as it's pulling it towards the center of the earth. But 1/2 meter isn't very far. So what happens if I take a bundle of pencils? Yes, these are wooden pencils. All put together, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pencils here. 16 times 5 is approximately 80 grams, plus the masking tape and the metal up here. I think we weighed this, it came out at 97 grams. So here we go. 97 grams versus 5 grams, 1/2 meter above the tabletop. Let's try that again. Let me get that about even. Oh, there's still something wrong here. They're hitting the tabletop at the same time. I've run the experiment 3 times for each one, because when we do our experiment, we want to make sure we do it more than 1 time just to see if we get the same data. Gravity is pulling everything equally, even though we have things of different mass or different size that we're working with. Now, there was this gentleman, Galileo, who hypothesized that gravity pulls everything equally. And he postulated, he said that if I drop a hammer and a feather at the same time, they should be pulled at the same rate. Well, I don't happen to have a hammer, so I'll use my big bundle of pencils. And I don't have a feather, but I do have this little sheet of bubble wrap here that I found in the back room. Going to hold them at about 1/2 meter above the tabletop. Whoa, now we have something going on. And one more time to get our 3 times. So now when we ask the student what's going on there, they'll say, well, this is bigger than this, and they're partially right. Our bubble wrap, besides the fact that the mass is still about the same as, the mass of this is somewhere around the same as 2 of these pencils, if we were to put it on the scale, possibly even less. But here's the thing. The surface area of the pencils is much less than the surface area of the bubble wrap. And because the pencils are much more solid, and because they move through the air moves around it as it goes down more efficiently, these pass through the air more efficiently than the bubble wrap. Because the bubble wrap, the air has to pass completely around it before it can get on the back side and allow the bubble wrap to pass. So therefore, Galileo was not able to prove that gravity pulls everything equally. Now, if you go to our video library, I've attached 2 videos. One's the Apollo 15 mission to the moon, in which the Apollo 15 astronauts actually took along a falcon feather because it was named after their spaceship, the Falcon, and they took along one of their geology hammers and they dropped them on the moon. There's no air on the moon, so it's just gravity pulling, and indeed, they both hit the surface at the same time. I've also attached another video for you to look at. It's from the BBC. It's about 4.5 minutes, in which they travel to the largest vacuum chamber in North America and possibly the world, and they conduct this experiment with a bowling ball and a feather. And you'll see that even here on Earth, if we can pump the air out of a sufficient space, gravity does pull everything equally. And when we did our lab report, all we did was we answered each one of these questions. What was our question? Does gravity pull equally? What was our possible solution? And that was either the student had to say yes or no. We kept it very simple. Our experiment, we dropped the pencils. We dropped singles. We dropped a single and doubles. We dropped multiple pencils. And every time, gravity pulled them equally. We recorded our data because we did it 3 times at least apiece. And then, in our conclusion, most of the students, I did have 2 students that disagreed with the findings, but most students said that gravity does indeed pull everything equally. We hope you enjoyed the video. Stay tuned for more videos, and if you missed us in class, you've now seen what we did in class.